Oh, hello. Welcome back, everyone. And this is Danny. In this lesson, I'm gonna continue on what we're talking about. And in the last lesson, we talked about flow pattern with streams, and we talked about limited unordered parallel execution. So in today's lesson, I'm gonna continue on ordered parallel execution while by using Node.js streams. So let's get right to it. So as we can see here, probably we have a whole bunch of tasks coming in. So, but we need to have them ordered. That means that we have the input in order. So we have to get the output in order. So the black one comes in, the black one comes out. First in, first out, this style. So, and also we have a limit or concurrency, which is 4 in this case. So depending on your execution nodes capacity, so you can choose the currency number you want. So here in this upcoming snippet, we just have the concurrency number, which is 10. So the concept or the request is pretty clear. Just we just grab a lot of tasks coming in and transform or just get them executed and get some of the corresponding results in order. So that's the situation. And for achieving this goal, we have to use a lot of methodology and also methods to support them. So here's some mechanism. So this snippet is going to be very complicated. So just follow me tight, please. And we just give you the guide you through this diagram roughly. Then I just combine this series with my snippets and just for you to understand all of the methods I used. So here we just leveraged a parallel stream, which is a transform stream, and just some of the readable stream coming from a input file, which is some of the tasks. For example, like a previous one here is we still have a lot of URL, HTTP or HTTPS website to for us to probe and to see if it's alive or not. So now the required request is you have to give the answer in order. So other condition and requirement were the same with the previous one, and let's get into that and just show you my snippet and guide you through some of the important points. So here we just as usual, we just use some of the third-party library like a split, and we just break this into two parts. The first one is definition of the parallel stream, which is inheriting from the transform, and we have our own constructor here, and we just define some other property here, and also give super initial as a instantiation, and the whole class a parallel stream or based on or running based on the object mode, because the upcoming or upstream data will be object a array of HTTPL URL strings. So we have to use our leverage object mode. So here we define the true, and here we define this property is promise queue, because we try to accumulate 10, for example, concurrent tasks or URL, and then we put them into the queue and let this queue running. So let's head back over to this diagram. So upstream data will be the URL string, array of URL. So when an array string comes into the underscore transform method, we just fire up a async uniform. Remember that this is a critical where our meet for probing task. So this is asynchronous user form. I put this user form, asynchronous function definition, into a queue, which is I mentioned before just now, and the second string, second URL comes into, and it triggers underscore transform running again, and then we put the second tasks or put second user form to the queue. Then one by one, we put when the 10th URL comes in, because our currency number is equal to 10, so sort of like we have to pause, right? Because we already have 9 user form tasks in the queue, but we didn't fire the queue to run. So for the first for the 10th URL come, when the 10th URL came in, and I paused the stream. Here the stream. I pause the stream, and there's no fire which is done. You remember the transform done. When you fire the transforms down, and this stream just going around. When you're done, is now get fired, and then the whole stream will be paused. So by leveraging this mechanism, I just let the done paused, then the whole stream paused, and then it's time to deal with and manipulate our queue, because our queue is getting full, and with 10 tasks, right? 10 user forms tasks. So I fire up or I use the promise.all and let it running. Promise.all, remember, just for the record, the promise.all is a ordered parallel execution statement or command. So it takes a array of promises or array of asynchronous tasks. So I already gave them an array with 10 tasks, asynchronous task, right? So I put this array into the promise all, let it running, and they run, and this statement will guarantee the order, the outcome, the results order, I mean. So because when your profile all getting fired, and that turns out that the 10 user forms are not asynchronous tasks will be running asynchronously here. So depending on the period of time that every probe takes, some of them will be pretty fast to get a response. Some of them will be pretty low to get a response, right? So we just set up a board signal, which is have 5 seconds as a timeout. So I just when I send out the probe, the timeout is 5 seconds. I just wait until 5 seconds. Then I just give them a verdict, or just I just give them is it alive, or is it something wrong, or it's probably this website is down. For example, after 5 seconds, no response, we just give it a judgment, and this website is down. And all of the result will be go into the result stream, remember we have this dot push. So we push our every probe's result into the downstream, in our pipeline. So we put this result into the result file. So but here we just notice that there's a period of time here. We have to wait, right? So when all of the 10 URL probe has the result, no matter what is yes or no, a probe result is yes or no, or up and down, and that's then another 10. So number 11 to number 20 URL will be coming. So just iterate this round and round. So another 10, another 10, another 10, and the process will be the same. And finally, all of the URL being consumed at the point in time, at certain point in time, right? So that would immediately trigger this underscore flash get fired. So this underscore flash getting called, but I just pause this flash we don't give him a done, right? Because at that moment, we still have running task running asynchronously, right? Here, we might have some tasks still running and without any result coming back. So we have to pause here. We have to pause here uh, until all the remaining user form task has been finished. So when all of the user form task or all of the probe task finished, then I run this done flash. This is underscore flash done. Then and then when this done is was running, and this underscore destroy will be running. So destroy all of the stream, and pipeline. Destroy themselves or destroy this parallel stream. So that's the whole algorithm here. So just by using underscore underscore transform then to pause every 10 URL and using this underscore flash done to pause until all of our tasks finished. So we kind of like we have to control the stream, because stream if without any control, stream kind of like automatically flow from upstream to downstream. So you have to pause because you need to manipulate the whole capacity and the whole order, right? So you have to guarantee or make sure the result order is the same as the incoming order. So let's get back to our the code. Here we define the definition as I told you that I defined this very important queue, promise queue, for me to control the whole tasks. And here's a underscore transform. So when every upstream URL comes in, so this will trigger this underscore transform to run once, and it takes trunk encapsulation method and done. So that's the I talked about the done. So it's running this one plus plus is mean will be incremented by one every when every task comes in, and the currency will be also be incremented, and have a console and give it a time step here, and here we just you can see that, and we push this asynchronous task into this queue, right? And here we didn't fire up, we didn't run this definition asynchronous task or function. We just put a function definition into the queue, and then here we just if this concurrency is less than the capacity, for example, is number one probe, is number two probe, is third probe, fourth probe, no problem, just go ahead and continue on. So it just fire this done to let them running. Then when every 10 URL comes in, so this block will be running. So we console log this, and I said tasks reached. So the concurrency reached. And then we just run this task, we just fire up this promise all, right? We fire up this promise all. Then 10 tasks will be fired asynchronously. And then when every result, a promise, I should say, promise of result came in, then this block will be fired. So we run this block for every value. We just push this value. This value is equal to this website is up. This website is down. This is a conclusion for probing. So we push this result to the downstream to the actually in turn to the result file. So just be careful. This push, this is stream.push. This push is sorry. Another push. Sorry, just this push is array push. So let's just be careful and just pay attention to that. And flash underscore flash is again is pretty much the same with underscore transform, and this if there still have a task left, we just fire up the promise all with the remaining task to run. So promise all with the array if there is some task here, and this is the same, and push the value to the downstream, and a console, and then this file. Please notice that here this is a little bit tricky in this place. So this block is asynchronous fired, or just this block. I mean, so this block, because this is callback block, callback asynchronous block will be delayed after this running. So within this underscore flash running, we actually, matter of fact, just this block will be running first, because this is a asynchronous block, right? So, for example, if this running is greater than 0, and this I just define this terminate CB is equal to done. So done is this flash done. So we put this done into our defined property, and then some at the point in time in the future, and this 10 task has finished, and then it's time to run this then block. So they just run this. So this if this terminated CB exists, it really exists, because this block already ran, right? Already ran. So if this terminated CB exists, then you just run it. So here we just after promise, all the promise came back, I run this block. This is run. So that means this done, flash done is running. finally running. So after all of the promise get done, so that's the tricky things to just draw attention on this the execution order. And also we have underscore destroy and underscore incomplete is pretty much the same with previous one. It's just here there's some cleanup and minus running cleanup drop here, and or if there's an arrow here, it's just emit arrow handler. And no, and here from here it is the main program. So for us, it's just a concurrency is equal to 10. You can change it to what you like. And here's the one command is a pipeline. Just organize the whole pipe. Here the first pipe is a file, which is URL s2.txt, in which there are more than 200 URLs here. Definition there, and the split. So we just split this file into an array, remember, and then we just new our parallel. And so instantiate this parallel stream we have defined, and we give it a concurrency as a parameter, and we have a asynchronous user form. This is user form function. Really does here, and you just try to organize or just normalize this URL string, and if the URL is empty or just undefined or none, just return done. Done is this done. This done is equal to incomplete something, and try this just await fetch. We just fire this header method, HTTP header as a method to probe every website, and give it a timeout, which is the 5 seconds. If this timeout expired, just trigger the arrow signal. So it should catch this error and just give the result value as some website is down, and just give it an arrow code. And also this done is incomplete. When everything is has finished, just incomplete to do some cleanup for every task. So finally we return result, because result is this value. This is string, because this is return value is in a await. That means that it return a promise of result. Oh, sorry, it's a promise. It's a promise of value of result. And also create write stream as a results TST. So result string will be flow to the final writable stream, which is results TST, and give it an error handler and a console. So I run it. Actually I already run this. So just scroll up and try to I think it's you know the whole series and the algorithm, and you can get everything, and just run. And this is some of the log here, and you can see this intrans. Every task will be triggering the underscore transform to run, and this every URL in transform, and every 10 URL, and they get paused and trying to wait for them to complete. And this is a complete time step. You can see that, which is probe and wait for this 10 probe to finish. And then we push the final result, which is to the downstream result file, right? Then another 10 URLs come in, and just process the same procedure and process with it. And here we have more than 200 probes a URL to probe, and that's so when all of the URL has been consumed or has been thrown into the transform stream, and then in the underscore flash immediately got fired with this time step. But at this time, we still have some of the tasks need to run or not finished, right? So we have to wait. So here we pause the flash. We pause the underscore flash. We wait until those final 10 or final not 10 final remaining task to be finished. And this is the final task to be finished and push. And then we remember that this is then block. This is a promise or then block. This is derived from that block, then the say underscore push value down, up, down, up. This is the final value probing result. And in flash task done, or all of a sudden destroy this whole stream. So show the all URL has been checked. So that's the whole everything about this snippet. So just remember that we can, with this series of course, we use and we just flexibly use underscore transform and transform stan. We also use underscore flash and underscore flash stan to kind of like control the whole process and to form an order parallel execution, to form ordered parallel execution, just by using this kind of tips and tricks to control the whole stream, to control, especially for parallel stream here. So hope that it helps, and you getting all of them, and just thank you so much for watching. And if you have some question and a comment, just leave it below. So have a nice day. Until next time, take care.